Welcome to
Nay.
Do it.
Channel Everyone. Okay, wow, that was surprisingly in sync for us. Hello and welcome back. I'm Isabel, and today we are talking about something that sounds like pure science fiction but is very much real. AI babysitting satellites in space.
That's a great way to put it, Isabel. Babysitting is actually quite apt. I'm JJ, and what we're really discussing is the critical shift from ground-based satellite control to on-board autonomy. When your satellite is on the other side of the moon, you can't wait for a signal to travel back to Earth to diagnose a problem.
Exactly, the delay is a deal breaker. This is about moving from telemetry monitoring asterisk to telemetry understanding. In real time, with the limited computer power you can actually launch into orbit. I'm Jiyoung, by the way.
So the big word here is explainable AI, or XAI. JJ, for our viewers who might think AI is already a mysterious black box, why is explainability so crucial when it's floating in a vacuum?
A brilliant question. Imagine your car's check engine light comes on. A helpful AI would say oxygen sensor failure. A black box AI would just say something is wrong. In space, with a multi-billion-dollar asset, something is wrong is a nightmare scenario. You need the AI to point to the specific reaction wheel, the specific type of anomaly, to allow for automated recovery or to send a very precise, actionable report to Earth.
And to add a layer, it's not just about pointing, it's about asterisk trust asterisk. If an AI system autonomously decides to fire thrusters or shut down a system, the engineers on the ground need to understand asterisk why. Without that trust, you will never get approval for true autonomy. It becomes a very expensive automated paperweight.
So the paper we're looking at introduces this concept of peepholes. I love that name. It sounds less like rocket science and more like spying on your AI. What exactly is a peephole?
It's a fantastic metaphor. Think of a deep neural network as a series of rooms, each processing information in a more abstract way. Normally, we only see what comes out the final door. A peephole is a tiny window we install into one of those intermediate rooms. We don't see everything in the room, but we get a structured, low-dimensional glimpse of what the AI is asterisk thinking at that stage.
Technically, they're tapping into the activations of a specific layer, compressing that data into a human-interpretable code. Like the AI is generating its own status report mid-process. The key is this report is semantically annotated, so a specific pattern in the peephole data might directly correspond to. Reaction wheel number 3 is experiencing increased friction.
So instead of just an alarm bell, you get a diagnostic code. You're not just told the satellite is sick. You're told it has a specific fever and where it hurts.
Precisely, and the beautiful part is the efficiency. This framework uses a convolutional autoencoder for the core anomaly detection, which is already quite lean. The peephole mechanism adds only a marginal computational overhead. That's the magic. Explainability without blowing the power budget.
Which is the ultimate constraint. You can't just slap a giant server farm onto a satellite. The research demonstrates this on telemetry from the attitude and orbit control subsystem, the system of thrusters and reaction wheels that keeps the satellite pointed correctly. They showed the peepholes could not only detect a fault, but help localize which wheel and even identify a asterisk bias in the sensor data. That's huge for practical recovery.
This feels like a quiet revolution. It's not about making AI more powerful in space, but about making it more communicative, more trustworthy.
That's the core of it. We are building partners for space exploration, not just tools. A partner needs to be able to explain its reasoning.
And this approach, these peepholes, they are a step towards that partnership. It moves us from the AI says so to the AI says so, and here is the evidence it's using. That's a fundamental shift for safety and operational confidence.
Well, my mind is officially in orbit. Thank you both so much for climbing down this ladder of complexity with me. It's absolutely fascinating.
Thank you for having me, Isabel. Always a pleasure.
Thanks, Isabel. Great conversation.
And thank you all for watching. We'll see you in the next one.